so my name is Jim Cohen from Applied Biology.
I'm Lihua Wang, I'm from chemistry.
And we're going to talk to you guys today about the Utilizing Plants for Innovative Research RU program that I guess began in some form around 2015, spring of 2015 at Kettering, but we had our first year in 2017. So we'll talk a little bit about the program itself. So this takes a lot of work to do. So while Lihua and I are, have our names on that first one, none of this could be done without everyone here who played various roles, and we can talk about that later on. But as you may see, and as we will try to get across, this program really took a lot of effort on multiple people from multiple departments from across the university. So in particular, Michelle, Cheryl, and Vani were really instrumental with Lihua and I, the five of us together, in putting together the RU program at Kettering. But everyone here was really quite helpful in ensuring that the program ran smoothly. So for those of you not familiar with the RU program, it stands for Research Experiences for Undergraduates. And it's a program by the National Science Foundation, and there are lots and lots of these different types of programs. We'll talk a little bit about ours, but they really run the gamut from being focused on engineering, geology, biology, all the way to Antarctic expeditions. And so here are some quotes that I pulled off the website that I think really exemplify the spirit of the RU program from the National Science Foundation. The Research Experiences for Undergraduate program supports active research participation by undergraduate students in any of the areas of research funded by the National Science Foundation. Projects involve students in meaningful ways in ongoing research programs or in research projects specifically designed for the RU program. And that really fits in well with what we do here at Kettering, as we are a very undergraduate focused institution, and we actively involve undergraduates in all aspects of research. The research experience is one of the most effective avenues for attracting students to and retaining them in science and engineering, and for preparing them for careers in these fields. And there's been a lot of research that has demonstrated that that is the case, and that having students participate in these different types of research programs really gets them enthused and gives them a really good understanding of what research is going to be if they go on to graduate school. And RU projects offer an opportunity to tap the nation's diverse student talent pool and broaden participation in science and engineering. NSF is particularly interested in increasing the numbers of women, underrepresented minorities, and persons with disabilities in research. And so that is definitely one of the goals of the program, and as you will see, one of the goals of our program as well. So the RU sites are distributed all throughout the US. It's probably no surprise that California, Texas, and New York have the largest number of them. But here in Michigan, they are distributed throughout the Lower Peninsula. And U of M in Ann Arbor down here in Michigan State certainly have the majority, but there are programs at Central, Grand Valley, and Oakland as well. And we are, I guess, Saginaw Chippewa Tribal College is a community college about an hour away from here. But we are the only primarily undergraduate institution on that list in the state. And so I think that is an interesting aspect of our program and something to note.
Then why do we want to have a REU at Kettering? And first of all, Kettering, like Jim said, Kettering is a primary undergraduate institution. So our faculty members have extensive experience in mentoring undergraduate research students. And our laboratories are facilitated with state-of-art instrumentations that can conduct research. And so Kettering has the ability to help increase diversity in science and engineering. And also by having an REU program at Kettering, which will help increase interdisciplinary research collaboration between different faculty members. And also, additionally, it may provide opportunities for us to attract students from community colleges. Last year, we have a community college student who is interested in transferring to Kettering. And also this year, we may have more students from community colleges join the program. Even though the participants of REU programs mostly are from colleges outside the host university, but we can have 1 or 2 students from Kettering join the program each year. And so this provides an additional experiential learning opportunities for Kettering students, and also the immersive research experiences the program provides give them a variety of laboratory skills, which will be very helpful for them for their future employers. Okay, in order to have our REU site, you have to propose a cohesive theme. For our program, the theme is utilizing plans for innovative research, Yooper for short. And this was originally proposed by Dr. Cohen. And because Dr. Cohen is a plant scientist, a true plant scientist among all of us.
The acronym is Yooper, which is kind of funny for Michigan. Thank you.
Okay. I'm sorry.
Sorry, Lihua.
Okay, but a number of us have been involved in a variety of plant-related research. So that's how it gets started. And the 3 main goals for the Yooper REU are, first, we want to bring a team of interdisciplinary researchers and students to conduct cutting-edge plant-themed research that will result in presentations in conferences and also peer-reviewed publications. And as you will see later in the presentation, 6 out of the 10 participants from last year have already submitted or presented or is going to present their research in a national or regional conference. And 1 other student is planning to submit an abstract too. And second, to provide immersive research experiences for undergraduate students who otherwise might not have other research opportunities available to them. For example, some students are from smaller colleges that don't have the research facilities. And finally, we designed the program so that we not only give the technical research experience to the participant, we also provide training in other areas of scholarship and workplace skills, such as understanding and primary literature and presenting scientific research results and how to effectively work in a team, and research ethics, and also interviewing and networking skills. In recruiting the students, we pay particular attention to 3 groups of students. First, students from the local geographic area at schools that do not typically emphasize research. Last year, we have 4 students from various colleges in Michigan join us for last year the program. And also, we pay attention to students from schools on quarter systems because the schedule of our program fits their school schedule better. And also, we pay attention to students from groups underrepresented in science and engineering, including minorities and women.
So this is a little bit of the timeline, sort of condensed, of how we went about getting the grant submitted, as well as beginning to administer it. So the grant was submitted in August 2015, but that means that starting in, I think it was late May, a bunch of us met and started thinking about this grant and began putting it together, working with OSR to get everything ready to go. And then it wasn't until early 2016 when we really started thinking and getting notification that the grant was going to be awarded. And we found out, if I'm not mistaken, sometime around March. So it was a little too late to begin the program in 2016. And so that was nice because we had plenty of time to get started for 2017, and we found out that that was very much needed. So there was a lot of logistical planning that had to go on. While NSF will publicize your program, you need to have a website to be able to do that, and that is just one way of publicizing your program. So we worked with Marcom, and they were very nice in helping us do a lot of advertising. We worked with HR to come up with the application process to be able to do this. We had to work with various people to figure out housing, meals, transportation, various types of programs that were going to occur. Lihua had mentioned some of these about professional development and particular scientific skills. So talking with people about some of the programs that were going to go on. This is just an example of some of the marketing tools. So this is one of the flyers that we sent out. There is our website, which has all the information on it right there. So just pointing those out. So once the application became live in December, we had to get the word out so people would apply for the program. And we were, I think, pretty fortunate for starting off. We had 69 applicants apply, and we worked very quickly to be able to identify the ones that we wanted to invite to participate in the program. As I said, there are a lot of these RU programs. Students are in general going to be applying to multiple of them. Not that we don't have the best one, but so it's good to be able to notify students early on. And sort of shortly after we did that, I'd say by the end of March, we had 10 students, which we will talk about in a second, in the program. And then we had a lot of planning that went on between March and the beginning of the program in 2017, dealing with a lot of logistics, particularly making sure the housing, transportation for the students, because most of them are coming from different places across the US, trying to get all of the programs that went on during the, I guess I should say, the various activities that went on during the 8 weeks of the program scheduled. The students arrived, and the program runs for 8 weeks, which we didn't mention before, but is kind of an unusual aspect. Most of these programs run for 10 weeks, but as Lihua said, we were targeting quarter system schools, and so being able to have the program slightly more condensed allows students that are at semester schools or quarter system schools to be able to participate without having to arrive late or leave early. We had assessment at the end of August, and there were a couple different types of assessment that we had. And since then, we've been reevaluating various aspects of the program, which we'll talk about later. And then we've been doing all of this over again. Advertising, getting the applications up and running, and recently, I guess about a week ago, we started inviting students to participate in the program. And so we're about halfway there with the students that we invited. So we're excited to be able to hear from the rest of them.
Okay, here are the 10 amazing students for participated the 2017 program. As you can see, we have 4 Michigan students and 1 Kettering student. The rest of the students are from various states across the nation. They are from Ohio, California, South Carolina, and Georgia, and Mississippi. And they're a group of students who are highly motivated, extremely hardworking, and have achieved good academic, have great academic accomplishments before joining the program. And after they joined the program, we were even more impressed with their ability. And in the short 8 weeks period time, and they learned the background of their research project, they learned the various techniques used in the project, and they produced a lot of useful results for the research.
And so when we started out, we had, let's see, what is that? 8 projects that were pretty interdisciplinary, I have to say. So, and we'll talk a little bit about this in a minute, but they ranged from what I would say are kind of, being the botanist here, classic botanical type work, dealing with looking at anatomy and morphology of plants from brownfields and doing phylogenetics. But a lot of the work focused on medicinal compounds of plants. And so we have a number of these projects here that did it. Let's see, a project with biogas that was collaboration between our microbiologist, Michelle, and Steve Nartker from chemical engineering. We had a couple chemical engineers who were involved in natural fibers, and a project that was looking at various aspects of mutation. And what you see with, I would say, the majority of these projects, while a couple of them span chemistry and biochemistry, a lot of them are really interdepartmental. Applied biology and physics right there, applied biology and computer science. Let's see, where are we at? Chemical engineering and IME. And so what we set out to do, given that we are not a large institution, is to be able to include a lot of people from different departments that are working on different aspects of plants. That allowed students from a whole different variety of majors to be able to participate. While those of us that were actively involved in writing the grant would have been from chemistry, biology, biochemistry, we really tried to ensure that students from a whole host of different majors would be able to participate. And I think sort of one of the notable things here is T, who was a student from Kettering who participated last year, their computer science major. And so not one that we necessarily would have thought would participate, but we're really happy that they did. So when I think about the program that we put together, and I guess we're giving this presentation so we can sort of toot our horn a little bit, there are a couple of notable aspects of the program. One, and one of the more interesting parts of our program, I think, is that all the projects are interdisciplinary. So if we go back here, again, I sort of pointed that out, that faculty mentors are from all different departments, or multiple different departments, but every student that was working on the project was mentored by at least 2 faculty members from what we would consider different programs or different departments. And so the students were able to get a lot of different experience and perspective as well from faculty that came at problems from slightly different ways. And as we said before, we as faculty are actively involved in the research that is going on. And so we're a primarily undergraduate institution, so we have undergraduates that are involved in the research very much with us as faculty. And so working with faculty from different departments, as well as just working with faculty in general, is kind of a different approach for these RU programs, where normally students would be working, undergraduate students participating would be working with a graduate student or a postdoctoral researcher. I think Michelle said when she was participating in her RU program, she saw, how many times did you see the PI?
I think I saw him once.
And hers? So it's a bit of a different experience. And because we have students on campus during that time, it's a bit livelier. We also had frequent meetings, at least weekly meetings, as sort of a group, as well as talking with the students early on when they arrive to see what they hope to get out of the program, and so that we would be able to, as faculty mentors, really tailor our approach to what students would want to get out of the program. Also, being at Kettering, I think that we all are probably familiar with the fact that professional development is an important part of it. And so that is a pretty unique aspect of the program, where every week there were professional development seminars that students had. These were related to graduate school and job skills, scientific ethics. Marketing and communications came in to talk about science communication. And so these types of discussions, which I think are really important to being a professional scientist, but something that we sort of expect people will get as they go along. But we really try to focus in on these particular skills. We also had skills-based workshops during the first week of the program. So students would be able to get up to speed if they didn't know how to use a micropipetter, or if they weren't familiar with doing literature searches, they would all be able to get to the same place. And there were weekly journal clubs that the students had as well, where they were able to present on a topic of interest to them, usually related to their research, and talk about it with their colleagues, with the other students in the program. Which sort of goes to the next part of there, which is really the development of a cohort of like-minded students. So these students were really into doing science. They talked a lot about doing science. They all lived together in 2 apartments in Campus Village. They'd go back and talk about science, which, you know, as science geeks ourselves that were mentoring them, that was pretty cool. And one of the really interesting parts of this was that the students really worked collaboratively to be able to better understand particular aspects of subjects. So Dr. Ryan and I had 3 students that were working together with us. One of them was T, the computer science student, and T helped another student learn how to use the software language R. And then that student helped the other student working with us learn how to use it. And so if you were someone that was kind of command line fearful, then it might be a little daunting. But with all of them spending a lot of time together, they were very comfortable and really willing to work with each other to try to improve their skill set. We also, if you saw before, we had a total of 10 students. 8 of the students were female, and we had a lot of female mentors as well. So we have, I guess we'll talk about this later, but we have a video that was put together, and what one of the students said was, it was really wonderful having all of these great female scientists as role models. And so it's pretty cool, I say this as the white male talking right now, but to be able to offer that opportunity to students that may not be able to experience that at their home institution. And then finally, we had a really, again, being at Kettering, there's an applied focus to a lot of the aspects of what we do. And so I think that the focus that we had was not only botanical, which is of course one of the more interesting subjects, but also the utilitarian aspect of it was unique.
Okay, here are some pictures we took during last year's program, and which shows some of the activities they do during the day. Obviously, they spend a lot of time in the laboratory conducting experiments and also on the computer to analyze data. In addition to that, we also have one journal club meeting every week and at least one seminar, professional development seminar or workshop each week, which we don't have picture here. But also they meet with their mentors frequently to discuss the progress of their research. And they feel confident to also suggest future steps for their research too. And also we planned a few field trips. One of them is to visit the Botanic Garden in University of Michigan at Ann Arbor. And this is a picture they took there, and Dr. Cohen took them there. It's a nice picture. It looks like they're not in Michigan, they're in somewhere tropical. And also, during the 8 weeks, it's not all work. They had some fun too. And we had bi-weekly picnics for the students and faculty and staff involved in the program. And this is a picture taken at one of the picnic, and they were flying kites.
Yeah, we had a really wholesome group of students. This was like their activity. They were really excited to go kite flying.
They get along very well. And
so the end of the program culminated in a poster symposium, research symposium. Some of you may have seen it. It was in the Great Court. And they put together really awesome posters. I mean, these things are chock full of data right here. And so, I mean, you can just see that they're like, when I make my posters, I feel like I spread things out a little bit more. But they crammed everything together from all of the research that they were doing during the summer. So these are, we've two of these, two others, and they're, one of the interesting aspects of this, something that I had said before, was that they're on all different types of projects from all different areas. And so there are, this one is on comparative morphometrics, whereas this one over here is on antioxidant capacity of black walnut. So a whole lot of different subjects that the students were looking at. And we were very fortunate. We had some judges from local schools be able to come over and evaluate the posters, which was really cool. And I think it's fair to say that the judges were quite impressed with what the students did. I mean, I think we were quite impressed with what the students did as well. And here they are at the end, very pleased that the poster symposium was done before we went up and had lunch. You'll notice there are only 9 students there. One of the students had to leave early, but we had a computer there with her face where she was able to talk to the judges, so that was kind of interesting.
okay. After the completion of the program was assessed by a common assessment tool developed by the Bio-REU division. And it's a survey the student took after they participated in the program. And it assessed the program in several areas. One is their ability of thinking and working like a scientist, and also their personal gains related to research work, such as their confidence in presenting research and their confidence in their abilities to do research. And also they ask questions, how much you gained in areas due to research experience. Those areas including writing, oral presentation, and statistics and research, and also I think making connections between different disciplines. And the last area is attitudes and behaviors as a researcher, how much they improved in that area. And also overall, what was their experience like in the program. And those are average scores for the question. Under each area, there are a number of questions they have to answer. They have to score it, and these are the average scores for the assessment result. And the first four area, the highest score possible is 5.0, and the last one, the highest score possible is 4.0. And also, the survey asked them to rate their abilities in these areas before and after participate in the program. And so these are the scores before and after, and these are the percentage increase for each area.
So they also were able to put down some comments, which were, of course, very nice to read because in general, they were they're fairly nice. My mentors are super helpful, responsive, and caring. They exceeded my expectations and inspired me to pursue questions I had in research. Felt like they cared for me personally, not just professionally. Let's see, I won't read all of them. I would say that looking back, if I had more reasonable expectations, they would have been exceeded. And so undergraduates have lots of expectations about what they want to do. They don't always know how to formulate research questions and think realistically, especially in 8 weeks worth of time. Let's see, did you feel challenged? Some aspects of my project required that I learn new concepts outside my discipline, but sometimes daily work was mundane. I feel like I should have chosen that little bit of a different one. However, overall, it was fairly challenging. Yes, I frequently worked outside my comfort zone and having to troubleshoot on my own to teach myself the necessary skills. And so, as I said, as we have said, the students are very interested in the subject. And I would say overall, as mentors, we gave our students a fair amount of freedom to be able to explore by themselves, which I thought was a really nice aspect of it, as opposed to sort of micromanaging what they did on a day-to-day basis.
Okay, like I said earlier, there are 6 students have already submitted or presented or will be presenting at a national or regional conferences. Those are their research titles and the conference they're going to present. And Emily submitted an abstract for a presentation in July, and then we have another student who is planning on submitted another abstract to a conference. These research may result in the future peer-reviewed publications too.
Yeah, it's pretty neat seeing that the students are, only one student, T, is still around. The rest we are in contact with via email or texting or something along those lines. So these students are, dedicated. They really want to continue their development as professional scientists, which is pretty cool to be able to see. So, as I said, we just finished up the first year in 2017. We are really beginning to plan for the next year in 2018 now. And as we went along, we learned a variety of things. Some of these are big things really to keep in mind, and others of these are small logistical things that are good to keep in mind. One that we found that are really important for productive research, having that cohort of like-minded students, people who all really want to pursue inquiry-based science. That's great. That's really critical for it. having the faculty be interested and involved in the research is really important. I guess I'll speak for all of us when I say that we were, very much checking in with our students, talking with them, making sure they were on the right track, that they were not floundering in any way, and providing these students with a lot of ownership for their projects so that they feel invested in it and, as you saw on the last slide, continue to feel invested in the project. As well as actually, I think, invested in the program and becoming a scientist. I think passion for science and engineering really goes a long way as well. When we were looking at students, and I think we've done something similar this year, we're very holistic in the way that we have been wanting to admit students into the program. And so students that really show a passion, that I think, and we've probably all seen this in our classes, that really allows for a potential deficit to be made up in academics in some way. And so students who really have an interest are really going to be driven. And we definitely saw that with one of the students that we had in the program last year. Advertising is important. I think we did a better job this year. I tweeted out the application a couple times to my over 100 Twitter followers. But trying to get the word out is pretty important, I think. We are not a large school, and so the advertising was pretty useful. But it seems like this year we cast a wide net, and we were able to get students from a whole host of different institutions, which was really nice. We found that students came with different backgrounds, different ideas of what they wanted to accomplish. And so I think the introductory sessions were really helpful in having the students get up to speed. But I'll talk about that again in a second. Statistics is really helpful for students to know. I think we encourage that, at least I know I encouraged it sort of later on. But trying to get the students to start thinking about statistical analyses, way to approach their data earlier in the program would be really helpful, and that's something that we are trying to figure out how to do better this coming summer. We had our scientific and professional development activities during lunch, like right now. And that ended up breaking up the day. If you are someone that is doing floral morphometrics, it's probably pretty nice to have a break from dissecting flowers for lunch. If you are someone who needs to do a 6-hour-long experiment, it really messes up your day if you have 2 of these types of activities each week. And so we're trying to figure out, I guess actually we have figured out, how to go about modifying this so that the students are able to not be taken away from these longer procedures that need to be done. And I think probably the biggest takeaway of this is all of this takes a lot of time, effort, and help to be able to do. And so we have shouldered, I guess, a fair amount of the responsibility in trying to get things done, but lots of other people have really been involved in making sure that this has been successful, and they've done so in a whole lot of varieties of ways. So again, we have all of these people that have been really instrumental in ensuring that the program is successful, being mentors, helping to provide some additional funding. Rob Blosser, who gets the brunt of all of the emails about the HR system not working, unfortunately. OSR, Marcom for helping to get all of these, helping to get the word out, and advertising, materials.
And our laboratory technicians and managers helping us getting the materials ordered and instrumentation maintained for the students' activities. Who else?
Cindy. Cindy, who was
Oh,
incredibly
yeah,
helpful in making sure that a lot of the logistics worked out last summer. And Taylor Lowe was a co-op student working with us as well, helping with that. I mean, I guess I can't stress enough that it would be really hard to do without a lot of help from the institution. And that's something that we've definitely found out. And of course, NSF.
And thank you for your attention.
The NSF-RU program, it's been around for a while. It stands for Research Experience for Undergraduates. And it's a great opportunity for an undergraduate student to kind of feel like what it would be to be a graduate student in science. The key is that in an REU, an undergraduate student gets a chance to act like a graduate student and do research like they would do in graduate school. So Kettering's RU program is really quite different than what you would see at other schools. When we welcome students into our program, those students are going to have direct contact with our faculty and not be working with a group of graduate students like they would be at a large university.
The REU here at Kettering, by design, is interdisciplinary with projects that span multiple fields of science and engineering and are advised by faculty from multiple fields of science and engineering. This past summer, I had students working in my lab with backgrounds in computer science and biology, and I myself am a physicist. We were working on projects that spanned all of those disciplines, and we're able to coordinate our different skills to make the best project possible.
Students not only got to understand what life was like in the research laboratory, but also be involved in journal clubs, professional development seminars, to focus on becoming a scientist, which involves a lot of science communication and outreach into the community.
The facilities at Kettering have been amazing. Like, everything has fulfilled my expectations. I come from a smaller institution and we don't have as many scientific instruments to do research with. So since being at Kettering, it's been super awesome and a great opportunity.
I think the aspect I enjoyed the most was just how much I've learned. I expected to learn a lot, but I've learned so much in such a short period of time, just about working in the lab, working in research, working with others, and I think that's made a big difference.
It's really, hands down, as an undergrad, one of the best experiences you can get because you're working directly with our faculty members and you're working in an interdisciplinary way, the way a real scientist is going to work.